we'll get things kicked off here this morning. So to keep on our topic that is ever so popular that we keep hearing about, health and wellness. I'm sure in the current environment with COVID-19, this may also be a topic that's getting dull on our ears, but I think it's important to parallel what we hear and see in the world around us to what we may be able to apply to the fuel storage and dispensing systems. And so every now and again, it's good to do a good fuel system checkup. And so we'll walk through some of the thought process behind that, how we can help you through that process and assist in doing your own fuel system checkups, and as well be there to provide resource, information, as well as some expertise from the industry to be able to put in place the right solutions, the right fixes, or as we like to say, the right prescriptions for any problems that you're facing with your fuel systems. So without further ado, we'll get started with our slide content. Now, we as physicians of those fuel systems, we understand the deeper physical damage. And so I think these pictures speak 1,000 words to what's really happening under the hood and what's damaging our equipment. And so you can see the scoring from solid particles, the damage to the injector poppet from excessive free water in that fuel, and additionally, we can see where accelerated wear comes from the decreased lubricity because of the excessive water content in that fuel. And that's all problems. Those are all symptoms and problems that can be addressed by improving our fuel quality in the storage itself. So some key questions that we as physicians of these fuel systems should be asking. And this includes you as that middle point between our end users, and even if you are an end user out there listening, and it's important to know that you can be asking these same questions and getting a better understanding of the health of your overall system. So you can more clearly communicate that to folks like us who can help you walk through what may be a bigger problem and put in place the best solution to meet and address those problems. So commercial-based questions, getting a scope or an understanding of how big the problem is, knowing how much fuel to deal with, and knowing what kind of budget or project timeline constraints you may be up against. Existing solutions, what may already be out there that we can work with or may have to be alarmed or concerned with to potentially replace. That incorporates pain points. What is the biggest problem that can create the fastest turnaround and improvement on results? So that way we go from dealing with the headaches of poor fuel quality, we improve our fuel storage to then quickly resolve those problems and pain points. Over and above that, any technical detail that we can gather helps us better understand the system. Being remote, having to work remote through this day of COVID, of social distancing, of working through web conferences. This is even more so critical. And so I would encourage you to gather this information as best you can. Sending emails and texting photos goes a long way to help us better understand what you're dealing with physically, what sort of conditions you may be dealing with, what that microbial growth looks like in your bottle sample. What does your patch test look like if you've got results back? All of this information helps to get a better understanding of where that problem comes from and the detail we need to help go from a very severe, aggressive problem to resolving the contamination, resolving that condition, and getting you back to a well-operating, healthy fleet and a healthy fuel storage system. So when we go into the field, just like physicians, we're going to do tests and run tests. So whether that's using an online particle counter like a CS1000 to do regular real-time monitoring of a system, implementing that or integrating that into a system that's already in existence, or using something like our FCU 1315, our field-based particle counter, to measure the contamination level of fuel and to give us a quick indication, a go, no-go, of whether or not there's free water present in that fuel. Once we know that information, we can have that data on hand in real time to be able to lay it against this comparative chart. So on the right-hand side is most commonly what we see in the field. Working our way from right to left is really what's common in the industry. So 1917-14 may be what you see out of the dispensing nozzle or in your equipment fuel tanks. The Worldwide Fuel Charter is that standard by which we go to for fuel storage contamination levels. That is the maximum level or standard for which you should see in your fuel storage tanks. And if you're not meeting that, that's going to be one of the first indicators to know that we need to address solid contaminant. Now, out the dispensing nozzle, we want to see improvements. And if you're looking at the fuel injection systems, we want to see fuel that's clean. And if you can get it clean in the equipment fuel tank down to a 1296, that means your equipment is going to be that much more efficient and reliable. So with that, I would like to transition over to Kelly, who can explain some of the prescriptions we would write to help meet those targets in ISO cleanliness codes and remove the water content to get us to those targets. So with that, I'll hand over the floor to Kelly. Thank you.